Hi, Steven.
Hello.
All good?
Yes, I'm. My car is getting repairs. So I'm in the
Okay.
lobby of a car dealer this morning. Yeah, a big back.
Awesome. Hi, Martin.
Hi.
Hello, sorry for the delay. I was crawling through my browser windows to find the Composite Schemas spec.
Good. Hey, Shane.
Hello.
I think we are completed. Oh, Shane is there, yes. Martin, Stephen. Yes. Seems in order. So we can start. Okay, let's start by reminding you all that by being here, we all agree to the GraphQL Spec membership agreement and the GraphQL Foundation Code of Conduct. Let's start by doing a quick round of introductions in the order of the agenda. My name is Michael. I'm the host today.
Hi, oh, sorry.
Yeah, I'm Shane from Apollo.
Derek from Apollo.
Martin from Apollo.
Pascal from Chili Cream.
Hi, I'm Steven.
Awesome. Kamil.
Yeah, the last one coming from the guild.
Yeah, refresh and your name wasn't there. Awesome.
Anyways, and I'm Benji.
Benji, last minute entry. Okay. We already have introduced everyone. Benji, we're waiting for a commit for your name. Okay, we have two topics on the agenda today. One is about keys and lookups. That is a continuation of the discussion we had last week. And I have a PR open for that. We can have a look at that. And then we have the composition spec structure that Pascal has aligned with the discussions we had. Are there any other topics you guys want to discuss that we should put on the agenda? Okay, I take silence for no.
Yeah, so maybe for context, these two things are actually great. Look, I mean, it's a great way to look back what happened this month, right?
Yeah.
So just because it's a primary, a primary working group.
Yes, awesome. Okay, then let's dive in. So last meeting we discussed that keys and lookups are actually two concepts that are valid on their own and do not necessarily tie in with each other, but can like complement each other. So I did a couple of changes to the spec text. Let's have a look at that. So in the source schema, I have mainly removed the keys from the examples just to get the lookup examples.
Did you mean to share your screen?
Sorry. Thank you. Yes, I did mean to do that. Yeah, okay, so this is the so this is my PR at the moment. Let's go back. We can see that all. So this is the PR lookup key relationship clarification 164. And this is basically the preview of this PR. And here in the source schema chapter under lookup, what I removed is basically from the examples, first the key directive, just that these concepts are not muddled together. And then I also clarified, because there was one sentence in here that kind of said that you have to have key directives for each lookups, that they have to correspond. But they actually don't. We still have, there are a couple of things we could still explore, I think, down the road. It might even be good if a lookup can also have arguments that are not necessarily key arguments. If we think about context or even about arguments that have defaults, they are not part of resolving something by key. I had an example, for instance, here, product by name. There could also be an optional argument like ignore casing or whatever. And that has a default that is not part of the key, but some additional argument that just happens to be in the lookup. And then it becomes really more interesting if you have something like context data that we don't have in version 1, but potentially could also play in the lookup, and that is then not keys. Derek?
Yeah, so I'll comment on the PR, but my first thoughts that come from it, I think it is, this change is it's actually confusing. At least will be confusing to the folks, because I believe the underlying issue is that there is no one-to-one mapping between the lookup and the entities, which are identified by the keys, but the lookups or combination of lookups will be actually used to resolve an entity. So having a lookup that returns a non-entity is not really, I think that's not valid. Well, it's valid, we can return whatever, right? But it should be that lookup should, or combination of lookups returns an entity, I think.
Well, it guarantees the return value of object fields, and like the major use case for that, and maybe the only use case we can think of right now, is entity lookups, so mappings to keys. But there might be other valid reasons for establishing a mapping between an argument and a return field. So, for example, I mean, this is sort of a weird example, but let's say you have a products by category, and category is an enum. In that case, you know that every product in that list has the category that matches the argument. I don't know if there's any like actual usage there. Just trying to come up with something. But I think there might be other valid reasons for sort of establishing that mapping. But you're absolutely right. I think in the context of this specification, although it makes sense to separate the concepts, I would still call out to the usage that we expect this to be sort of primarily used for. So I would still call out to entity lookups and keys here.
Yes, and we do. We have here a sentence that says the stable key is defined by the arguments of the field. Each lookup argument must match a field on the return type of the
Yeah,
lookup
but
field.
that's a bit confusing because it's sort of mixing the
that's-
two concepts.
Yeah, it's like there is still contention in this.
Yeah.
It's
I,
not. It's not.
I posted a few fragments in our Slack channel, and I mean maybe some
Yeah.
of that language or the example even could be useful here, but I'll comment on the PR as well.
Yeah. Yes, that would be good, because like in the PR, let me get PR. Let's open separately. So this here, like before, we had the directives always in here, and we always had them with must, like they must be there. There must be a correlation with keys and lookups, and yeah, that's simply not true.
I think it might be helpful to have a nested lookup example in here, because that's sort of the primary motivation for separating the two concepts.
Yeah, that's also down here. Like there is polishing needed, so that because that's also my main concern, because I'm talking about keys here also, and because I took out the keys, it could confuse the two concepts, and maybe we take the language completely out here about key. I mean, we have to experiment a bit with that. We don't have to merge it like quickly. Just let's get it right.
Yeah.
I have but by the way, I had also a more complex example for this, like the union example, because at the moment it's also like if you have this example, you have these two fields here, then we expect them to be also on each of the object types that are the possible types of this union. And this, in fact, you can work around that with the is directive, right? And a one-off input, for instance, then you can say, okay, if it's this type case, you have this key structure, and otherwise this. But I left this out as an example. So at the moment, I don't know if that's too strict, but if you read up on that, just comment on everything that you think is not good. So the nested example is this one here, where you have a product by ID, and the product itself has a price by region. So you can get the product, and then you can pass in the region here, which is then a price entity, which is not unique outside of the context of price. So within a product, maybe we find a better example, but within a product you have prices, and these prices are valid for a region. But like the price object on its own is not enough.
Yeah.
I think for the nested example, I think the correspondence with a key is essential to showing sort of the workings. And
Yeah.
as an example, maybe the skew example that I used in my fragment could be helpful here. So the idea there is that a UPC is sort of a universal identifier for a product, but a skew is usually dependent on a particular seller. So if you want to do a lookup by skew, you first have to go through a particular seller.
Yes, I go through your proposal text that you had in the Slack and then integrate it. But you can also comment on the PR if you have more on that. But I will go over it and try to incorporate.
Yeah, with the nested lookups, I think there's also yes, there you can have like those combination of lookups to identify the entity, right? But it is also a possible scenario that you do have multiple layers of lookup, but each one of them is independent, right? So the secondary lookup could be by some unique identifier, which uniquely identifies the things also, right? Potentially. Right?
Yeah,
So
yeah. The interesting thing here is with the product price, is that product price in traditional Apollo Federation would be data, right? It doesn't have an identifier. Like the price itself as an object is not really an entity, but you can build now where you can resolve then particular pieces of data, kind of like an entity, with a nested structure.
Well,
So this, go ahead.
I would say if a customer came to me and said this about Apollo Federation and they were trying to do lookups based off this, I would tell them that they should make product price an entity, and that the key, if you got to go the type product price, the key should be a combination of region name and price product.id, which you have actually there already, and we could do as nested keys like that. So
yes, I was most thinking in align the range, like in the document DB, you have kind of embedded objects, and this was more in this direction. But if you have like, typically these things have entities, but we can update the examples.
Yeah, my point was more so like, yes, when you have those nested lookups at the levels, they can use the combination of those, but it's still perfectly fine to have entities and this regular lookups levels below, right? So product has a review, right? And the review has a unique ID per se, right? That you can uniquely identify. So that could be still a very same as a root level query to have the lookup there, right? For that.
Yeah, it's also with the GitHub example, right? The like technically the repository could have an internal identifier, could be an entity inside. Like from the outside model, it could still be that you always go with the organization lookup key into that.
Oh, sorry. I think I'm confusing folks. Yeah. So the lookups for the reviews would have to be a root level query because it wouldn't make sense to have it as because in order to jump to another subgraph to it, right? So that's sorry for the confusion.
I mean, it wouldn't have to. Like, I don't think we need to say that it would. Like, the spec doesn't say you need to have something on the root to be able to access it. Like you can still have a global unique one identifier, one key for review, but the only way you can access it is going through a root product and then a review, just like a repo or organization and then a repo. Like, yeah, I don't think there's anything that's...
Yeah, so key would actually function the other way around there. So if you were to get at a review through some kind of complicated path, you could then fetch a unique ID for that review and maybe use that to jump to another subgraph. But unless you have a root level lookup for that like review ID, you wouldn't be able to jump directly to a particular review within that subgraph.
Yeah. So for this spec text, I think that's actually a good distinction, which is when you put lookup on a field, like the tree and path and how you got to that field should be irrelevant. Like it's helpful for like users of the API, but like if I'm just looking just at the field price, right, on product, like, and this is a lookup. Like this is saying I should be able to get a unique product price type by using this particular lookup resolver. So like that, then the argument should be unique, right? I think this is what Marty, you're saying, like that maybe there is a relationship of the keys and the arguments should actually still be pretty tightly coupled.
I wouldn't have, because the lookup concept in itself could like the inputs to a lookup could be also something that is like the output needs to be stable. Like for what you pass in, it should have a stable output. But think about lookup that does a first or default thing. It would always first or default to the same thing, but it's still different than having then like the arguments there could be a case where they are not enough to identify an entity.
Or they way too much.
Or they're way too much if we're
That's
talking
one-
about
that's
what I
one-
mentioned before with
Yeah.
context.
I think
That's
more
one of the
more and with filters is fine, but like if you don't have all the keys to uniquely identify an entity, how are you
Yes,
going to look
yeah,
it
yeah.
up?
No,
Like,
you still need to be able to get there, but it doesn't have
Yeah.
to be on that particular field. So in this case, for instance, to uniquely identify a product price, the region name is not enough. You also need the product ID,
Exactly.
like you said before. So the key would actually refer to the product ID and the region name, the key on product price.
Yeah.
also
That was the main point here. Like the price, if you just look globally at the price, it would be not unique. It's only unique within a product. Like that would be the key.
Well, the main point where they do not, I think the difference is it's a fetch key, right? So if you have a product, if you have a product and you have a region name, you can fetch product price. That's basically the thing that you have to fetch. Now we cannot express this on product price as a key. Because if product price doesn't have a reference to product, which we may not have.
Well, I mean, it does in this example.
In this example, it does.
Yep.
But if it wouldn't have this field where the Michael has put his cursor on, if it wouldn't have this field, there is no way to uniquely identify this. Because from the point of view from the product price, you don't care if someone fetches you uniquely, because the key is defined, the fetch key, so to say, is defined outside of the scope.
but then why would you need to annotate with lookup if you can't uniquely identify anything?
Well, you can, as soon as you have a product, right? And
Yeah, but let's say product price didn't have a product reference. So the only field in product price was a region name and a value. So it's not an entity. It's just a type, a value type, as we call
Yes.
in Federation. And so it's not an entity. Why are we annotating the price field without lookup at all? Like, what value does that give
you
us?
can,
Like,
as soon as you have a region name and a product ID, you can fetch this. So that means that you could fetch it across different
It's kind of a hierarchical composite key. Like it's kind of an entity. If
but
we
then
look at
how would
the-
other subgraphs refer to
Yeah,
that they're
yeah,
referring to
yeah,
that
I mean,
particular like?
Yeah, you can refer to it. You just need the product ID. It's the same with the GitHub repository, right? You need the organization and the repository to refer to it.
But where does the other subgraph? Like, this is subgraph A. If I'm in subgraph B, how would I say I want to add a field to product price? Because that's what I'd be doing, right? It's like I want to add something to product price. I want to add more data to it. Like, how would I? Like, I need a key, right?
Yeah. But you have a key. The thing is that the really confusing thing at the moment is, right? In this case, we could even express a key, right? We could say product price, have the key region name, and then you have to go in product and take from that the ID, and that is the key. But one confusing thing in doing that is that the key is kind of in reverse from the fetch order.
So I would argue that basically, like in the situation that Shane you described, that you want to jump out of it, I would imagine there you would have a different key, basically unique product price, whatever, by ID. That this is what I was talking about, product and reviews, right? So in order to identify for that product, you would have you would jump to look up to the product and not a lookup for the reviews, right? In this path. But in order to go in another graph, right, you would have a reviews lookup by ID, so you can use like a different key to jump from the subgraphs, right? But it's so that's why to me it sounds like the lookups should be tied to the entity concepts, but the stuff that we wanted to just the define is that multiple lookups can result in a single entity lookup, but it's just there's always at the end of it there's an entity somewhere.
So when you say should return an entity always, it must return
Must,
an entity
yeah,
is
must,
what you
Yes, must.
yeah.
Question.
I don't actually think that's right in the case of nested, because you could have lookup fields that return like sort of namespace value objects or value objects in general that are not entities themselves.
Yeah, but then you just should, but then don't add lookup. Like, why are you adding lookup to it?
You're adding lookup because you need the semantics to establish correspondence between the arguments and return fields that you're going to use later on in that nested lookup to map to a key. So it's
Yeah,
it's not at the level of a single lookup that it should return an entity, but sort of
Exactly.
the
It's a combination of
the main use case we're looking for is one where at the end of a nested lookup, I mean, in most cases you would return an entity. I mean, that's sort of what that's what it's for. But we can't actually like we can't write that down as a rule at like the single field level, because a lookup might actually be part of a complex path and would not itself return an entity.
Yeah, the confusing part at the moment is not I think the use case is there, and I think it's good. We are just missing precise language for it at the moment.
And maybe we need some concrete examples that
yeah
make sense to people. I think that would help.
Yeah.
Yeah.
So I would say if it gets confusing to us, who are familiar with this space, I would say this is going to be very confusing to other folks reading this back as well.
But we also have
Steven?
to it's a lot of federation. So the key is required in a polar federation to do distributed schema. And with the composite schema specification, we don't need it for it to work. I'm not saying we should stop it, but
you still need it for various reasons. But I think Stephen has its.
Yeah. Well, I'm just wondering. We're talking about whether something is or is not an entity, and maybe that's partly just kind of a philosophical question, like what makes something an entity. Like if you can look something up by we'll call it a key. Does that make it an entity? Or does it have to have something else?
I think there are two directions to this, and that's why I think it's important to still require key to establish an entity. So the lookup gives you a way to get to a particular object. But what the key tells you is that, like, no matter how you get there, like you might not actually get there through a lookup. You might get there through like a list of recent products. What the key tells you is that you can uniquely identify those products in that list through a particular combination of fields that you can then use to jump to another subgraph. So the lookup path is just like one way of getting to an object, but it just tells you, it's basically it's the input side. It tells you how to enter a subgraph, but what key tells you is how to exit a subgraph, if that makes sense.
Yeah, I mean, technically you could reverse.
No, but because there's no unique path. Like in the case of a recent post, for instance, like what does that tell you about the like if you have recent posts, a list of products, that doesn't tell you anything about like the
you're right,
many potential ways. Yeah.
But if you what I mean is, like, technically the composition could look at the lookups and infer from them the keys, and that you still have in the gateway configuration or what not, you have then the keys. Like, you need keys, but you could also infer them.
I'm not sure. I'm not even sure you can reliably infer them because it's a graph and there are so many possible paths through lookup fields even. Like how do you actually establish which ones are relevant for identifying a particular entity if you don't have a key directive on that entity type.
Like how you like all the
So,
nested.
so for instance, in
Yeah.
the product price case, like
Yeah.
how are you going to know that product ID is relevant to identifying the product price?
Because we like what we do is there are rules how these can be nested, and you have kind of a directed graph from a query, and you walk down that with the rules for lookups, and then you have all the possible lookups, and you have all the possible hierarchical keys.
No, but there's no guarantee that the product ID is relevant to the price lookup. That's just like that's implicit in our understanding of it, and that's what we're trying to make explicit by using the key directive. But the fact that like a repository name is only unique within an organization, that's not actually part of the fields, part of the lookup fields.
Yeah, what we say for the lookup is that we have a stable outcome, right? If we pass something in, then we always get the product out. And if that has a stable outcome, and that has a stable outcome, and you put them hierarchically together, then also the pass has always a stable outcome, and then you have a key.
Well, I mean, but you get a large number of keys with fields that are not necessarily relevant to uniquely identifying the entity. So that's why I think it's important to be explicit about keys.
Yeah, I see the key in some cases also, like if we talk about caching and stuff like that. Then
no, not just caching. I'm just talking about this use case here. Like the fact that product ID is relevant for product price is not specified in here anywhere.
Kind of.
No. I mean, price could like well, the GitHub example is clearer, I think. Like the fact that you go through an organization and then there's a repository by name lookup, for instance. The fact that that repository by name is only unique within an organization, that's implicit in there. There could be a requirement in that API that the repository name is globally unique. So we cannot sort of infer that you need both organization name and repository name as a key.
So
I
think we might be bite shedding over here and getting too much into details on this right now. What I would suggest is that for simplicity, I would go with a stricter version of it. That the lookups, well, they have to end up with an entity, and multiple lookups can end up in an entity, right? So in the example here, the product by ID has @lookup, that's a root level lookup. It has to return an entity. The nested lookup there for product price is actually results in a combination of those lookups to actually uniquely identify it, but still results in an entity. So I think having this sort of like implication for now, it's probably make it simpler. We can lift out this sort of requirement in the future for the root level stuff. So like the product could not be an entity in the future, for example. But I would start with a more strict version for now. But
Benji?
Did we lose Benji? Or
It seems like it.
Yeah, there he is.
Hey, sorry about that, folks. I had to disappear. My front door was open.
oh,
Weird.
if
Children.
there's like an intruder with an axe and like in the blurry background, we'll try to warn you.
That'll be the doorbell, which will explain why the door was open, I think.
Not sure that explains it actually.
Yeah, I think you removed order.
Yes, as suspected, children. Right. Yeah, so I just wanted to chime in a little bit. I was trying to think through this stuff with you. And for this particular example, it might be that the price, for example, doesn't depend exactly on the product, but on a property of the product, which might be something like country, which might be shared with other entities. Really what we're thinking about, I think, is like entities, like correlation. There may be multiple paths to get to a particular thing. And so if you can get to something through two different paths, but that object doesn't have those properties defined on it. So if, for example, we didn't have the product written in this example, how do you know that those two things you've got through those two different paths are the same thing? And I think you need keys in order to do that. Is that right?
That's what I would say. Yeah.
Yeah, so this is, by the way, just one thing. Like when I described the keys, yeah, by applying the key directive, all reference to fields becomes shared. Yeah, that's just an addition. Key. Yeah, I think that the key directive is used to designate an entity's unique key, which identifies how to uniquely reference an instance of an entity across different source schemas. Like we have this as a language also in the practice.
If I'm understanding correctly, and keep in mind, I haven't read the detailed spec text on this, so I might not be. What we're effectively saying here is that there's a difference between root level lookups and nested lookups. With a root level lookup, the arguments to it kind of implicitly make a key. But with a nested lookup, they don't necessarily, because there's some context that comes from its parent. Is that accurate?
Yeah, I would say in both cases there's not necessarily a one-to-one correspondence, but it's definitely stronger in the nested case.
Yeah, it's yeah, if there is a lookup path to get something, that is also something to, it's not necessary to identify this thing, right?
No, and that's why I think it's important to clarify sort of the difference between like entering a subgraph and exiting a subgraph. I think that's a helpful distinction. But we may need to write that down to make it understandable.
That's good. I think we're making progress on refining this, but it needs definitely more clear language, and we have to really distinct these two things to make clear what they are and what they are not.
Yeah.
Okay, I'll go through your text, and you can also read through that, and then we can, like, over the next week include more language and examples. Shane, you wanted to show something? Sorry, I almost dropped that.
It's fine. I'll put it on the PR comments, but we can move the conversation there. But basically I started drawing visually things out, and I think this will help us also explain like the graph entering and like where can I get to a node if the node's coming from outside and not like a path down, like that's a lookup. So I don't know, I think it helps us all see it. So let's do that in the PR.
Yeah, and it's like from the discussion this week and last week, it's not clear enough. So we have to get more specify it clearer, and also get maybe more examples also for us, just to that we have a common understanding. Awesome.
Well, I think one important can you share again quickly? Because one important thing why this came up was that there is one thing that we also have to consider. We're talking about nested lookups and complex keys now, but it could very well be that you want to return product by SKU, and you want to extend product by SKU from another subgraph, but you don't really want to make this field shareable. And then you basically, if you not expose it on the other subgraph, you can also not define a key on this subgraph, right? So
No,
Yeah,
I think
so-
I think a key field needs to be shareable. I think that's
Yeah.
yeah, but
Yeah.
you wouldn't need it to be a key. You know, if you just have on one subgraph, you just have a product by SKU or product by slug, where you want to extend the product and you get
Yes.
slug or the SKU or the ID, or you just want to add fields to a product and you want to add fields to a product by a specific lookup, then it wouldn't have to be, it could be a key in the context of the whole domain. Like the SKU would be the key, but I wouldn't have to declare it on my subgraph.
I'm not sure I understand that use case or whether I agree with it, because I would say a key is sort of what defines an entity and defines the ability to jump between subgraphs.
Yes, but the point being is, if you have two identifiers which do not match, you have two different paths from a lookup to get to the key. You may not have the same data. It's just that if you, for example, you have it's the MongoDB or blob storage example. Maybe you store metadata for a product, and you have somewhere a mutation async batch process, something that creates metadata. And now you could say that I store the metadata by ID and I store metadata by key. But if I have the key, I don't know the ID. And if I have the ID, I don't know if I have the ID, I don't know the SKU. And if I have the SKU, I don't know the ID. Now,
I mean, I think the question is whether that's a use case we want to support. It's definitely, I mean, it's not a use case that's supported in the current version of Apollo Federation. Like the assumption is that if you define a key on an entity in a particular subgraph, those fields are always available when you have a reference to that type.
yeah, I think that could be fine.
Let's make I think the best way forward is to make concrete examples, because like this way it's also much easier to follow. And let's discuss on the PR. And one thing I just want to point out, like the thing about shareable, I just outlined it. We didn't have it as spec text so far. So I defined that by applying key directive, all referenced fields become shareable, even if the fields are not explicitly marked as shareable, right? So if we have here ID, this is shareable, and this would be a composition error, right? Because like this is neither shareable nor a key on subgraph B. So
Yeah.
it should have a composition error.
That makes sense to me. Yeah.
Okay. Yeah, let's work on that and find a couple more examples, and I think then also we get the right language and get it cleared out, because I agree with Derek. If we don't, if we all have different views on that and different ideas what it means, then it's problematic. Like we should.
It's one of the
Yeah.
core principles of composite schema.
Yeah, we have to understand what it does and what it's supposed to mean, and then we can move forward. Awesome. Let's move to the next topic. This took longer than I thought.
That's fine, because this will be very short. So what I was doing, I actually want to more than I in the end did, but I think that's a problem that software engineers anyway have in general. So we discussed, can you see my screen?
Yep.
Yes.
Okay. So we discussed the restructuring of the specification text, especially about the schema composition part. And there were multiple pull requests open. And we at the moment have just general, I believe, 55 issues on the composite schema spec repository. And I start closing the ones which we have already discussed, because they're aging and we have already defined how we want to solve certain problems. And for a lot of these, I need to make changes to the spec, which is fine, but I needed to get it into this format first. Because if you don't have it in the right format, I can't do pull requests, because then essentially we'll just end up in the wrong place in the pull request. So we have, I believe, decided that we want to do it like this. So we have the schema composition, then we have 5 subnodes. We have the validate source schema. The validate source schema now has different steps or different chapters. For example, validate the type system, where everything is validated, which is type system related. Then we have everything which is external, everything which is related to the key directive, everything which is related to lookup and whatever. And this gives it a bit more structure and organizes it a bit more. These were all pre-merge validation rules. They are now rewritten and merged into validate source schema, because all of these validation rules in here can be validated on a single schema. So you don't have to have context of more than one schema. That makes it very, very easy to understand what these rules do. And as soon as you have schema A and B, you have to decide, do you need the context of the merged schema? Then it's a post-merge validation rule. And if you need the context of just all schemas, and you need to validate that the merge process doesn't fail, it's a pre-merge validation rule. Here again, similar structure. We have validate type system, where we check if the type can't match. And this, for example, is a good example for what pre-merge validation rules are. It's we have to verify that we are able to merge 2 object types together. And if the types do not match, if you have an int and a string, we will not be able to merge. And that's all of the rules in the pre-merge validation have exactly this behavior now. These are required to run through, otherwise we're not able to do the merge properly. And then we have the merge, which is just all of the rules. And we have the post-merge validation, which again is structured like this, where we now need to have the context of all of the queries, of all of the schemas, for example, to see if we have an empty query type or not. Because theoretically, a query type can be empty on one subgraph, on one source schema, that's fine. But if all of the source schemas do not define a query type or fields on the query type, then it's impossible for us to fetch. So, I mean, in GraphQL, all of the source schemas obviously define a query type. It would be invalid GraphQL, which is one of the source schema validation rules. But if you make all of the fields on the query type inaccessible, you do not expose any fields on the query type. This could end up with no queries. And these are the post-merge validation rules is everything that needs the merged context. For example, we have an empty merged object type, or we have non-nullable fields cannot be inaccessible, because we only know this once we have merged everything together.
Pascal, once you've merged everything together, you have like the one final schema, right?
Yes.
So should one of the steps here not simply be to perform all of the standard GraphQL schema validations, rather than having a rule specifically to, check that the query type isn't empty? Like, that's already a check in the main GraphQL spec. So just calling out to that, I think, would simplify this down so that you only then have to worry about things that are specific to composite schemas.
Yes, I believe that having so I agree that we should run the validation, but that should be like a very specific error. It could be that something, in the specification, maybe we made a mistake and something went wrong. So the validation must be run anyway by an implementation to be sure that this is a valid GraphQL server that we compose. But we could be with these error codes, we can be very specific and hint to the user what went wrong. So we can, for example, if you get a no queries error, there is actually only one possible case how you can end up with this. And that must be that all of the fields are either internal or inaccessible on all of your query types. And therefore, it's like we could say that there's no queries, but what does this mean? because it's a generic graphical error, right? But if we do it specifically, and the rules are very simple, we can actually do this first and then tell the user that maybe you have to define, you have to at least define one public field. These are your inaccessible fields that you have. Just
and it could like the graphical validation is for a schema is a lot more than what could happen. Like when we merge a schema, there could happen very specific errors where we violate schema rules, like object types empty and stuff like this. But not everything can happen that we have specified as schema validation rules. So it's a kind of a subset.
Right. Yeah. I'm wondering whether some of this is just debuggability help, and if so, is effectively optional. Like if someone wanted to implement this spec and they wanted to do it in the minimum amount of time, and they didn't really care about error messages, that kind of thing, like could they just do the regular GraphQL schema validation, which they've already got tooling to do, and then a couple of extra checks if needed? Do they actually, like, is the new queries check actually vital?
Yeah, so I would say there's a handful of validation rules here that would be covered with the standard validation. For example, no queries, only inaccessible children, which essentially is the same as empty merged object type. Then we will have a few more here: empty merged input type, empty merged whatever, union, and so on. So these theoretically could be covered by the normal validation. What is a bit more tricky is when you, for example, say that you say the provides field is invalid, or the input fields cannot reference inaccessible types, where you actually say that, well, it would be covered as well, but it would just say that the input type 2 is not defined.
Yeah, there is one specific distinction. I think why we have that is also to guide the user to like what is wrong. Often this happens because fields are inaccessible, marked inaccessible, so they are actually there, but we don't want to have them in the public-facing schema. And then you kind of want to also guide the user there. Okay, if you have this issue, you probably should mark the type itself inaccessible so that it is being removed. Technically, we could also just remove them, but it's better to have the user like, is it an accident that it's empty, or is it meant to be empty? And by putting inaccessible then on the type, it's kind of more clear. So it's kind of debuggability, but also to like the user of the tooling, that they have clear guidance.
Yeah,
Shane?
I'm in agreement that we should specify these specific area scenarios and give them a unique, distinct code that should be probably shared across implementations. To Benji's point, should we maybe make these error, the fact that they're error code, they're a specific code and it is an error is fine, but like, do we must require that all implementations return this specific error code? Maybe not. Maybe we could simplify and say, like, as long as you validate and return and don't return and say, sorry, something went wrong, like you're spec compliant. And then like, if you want to help and be extra debuggable, like these are the error codes you should return, but not like must return.
Yeah, regarding the error codes, I always found it a pity that we don't have error codes for the GraphQL validation. That's why we mainly put them in.
Yeah, that was going to be another topic that I raised, which is like, it's been mooted a number of times putting error codes into the GraphQL spec, and I don't think anyone's like vehemently opposed to doing so. It's just no one's put in the work to do it. So some of these things may be addressable by that, but the kind of errors you'd get out of that would be like the type defines no fields, which isn't as useful as saying there are no query fields, perhaps, for example. So your errors are more specific, and I recognize that, and I see value in it, but I also am not sure that this should be a required feature to implement composite schemas. This is a great feature for a full composite schemas implementation to have, in the same way that connections in GraphQL schemas are a great feature to have to support like cursor pagination and a standard across the ecosystem. But those are not part of the main GraphQL spec, and that's okay. And I feel like this also is not necessary to the functioning of composite schemas. It's a nice to have. It's an addition that makes it easier to debug, easier to understand why something has failed. But I don't feel like it should be necessary to implement this.
So how would you do it, Benji? Should we I think it's useful to have it in the spec because you understand a lot of things also better from a spec standpoint, I think.
Yeah, so from my point of view, I think this should be either an appendix or an optional section. I think there are probably rules here, I don't know because I haven't gone through them all, that are actually needed in addition to this must be a valid GraphQL schema. But I think this must be a valid GraphQL schema is such a straightforward requirement to add that the ones that are already covered by that should be optional. So I would have effectively at the end of merge, or maybe as hang on, let me think about this. You would want this to be done first, right? Because you want the more specific error codes first. So you would have maybe optional post-merge validation, which would be specific error codes, and then you would have required post-merge validation, which would be this must be a valid GraphQL schema.
Shane?
Yeah, I was going to propose another idea, which is just we can make 3.4.1 validate GraphQL, and then that's just the rule, the error code, and then the sub rules underneath that could be optional. So we can say everything under 3.4.1 is completely optional. It could be have these codes, but the rule is generally just it's valid GraphQL, and then everything like 3.4.2 can become validate composite schemas type system, which has unique rules about the type system and composite schemas and whatever that is.
I mean,
I
just looked through the rules now, and this one would be called by GraphQL validation. This one would be called by GraphQL validation. This one would be called by GraphQL validation. This one as well. This one as well. So the only two rules which I found, which it's probably just these two. And these one, because here's about provides and requires, I believe. So it could be that you have issues. Require is easier, right? It could be that you require the field which doesn't exist, and that's something that we only know. We only know all the fields. Well, we only know. It's much easier to do it in post. You can do it as a pre-merge validation rule, but if you do it in post-merge, they're just there. And in pre-merge, you would have to jump from schema to search for a field which is there. But if we take all of these rules and we move them under a generic, if we take all the rules which we don't need and move them under a generic validation step, I'm generally thinking, shouldn't we just find a way to define these two, because these are wrong anyway, and then put them as pre-merge validation rules as well?
Yeah, I think also from a testing standpoint, if you want to validate your outcomes of composition, it would be very good to have these error codes.
Yeah.
It's debuggability, but go ahead, Derek.
Well, those could be defined as a pre-merge validation. I think it's actually easier to do it post-merge because of stuff like inaccessible. So yes, your requires and could be perfectly valid in this graph or multiple graphs, but one graph just sticks inaccessible on that field somewhere else, right? Which blows it up for everyone, right? Which is something that could be, should be. It's much easier to catch once you have final graph.
Yeah, but this is anyway.
Yeah, the thing is, what I would not like this to be an appendix, because like it would be good if actually everybody implements in this way. Then we have a much better ecosystem compatibility.
Are these error codes the same today as Apollo Federation outputs? Because one concern I know our engineering team is going to have is like we have to go update all our error codes, like if they're not exactly the same.
Kind of some.
Not all of them. We changed a few of them because they were just way too long.
Okay,
But
so
No, not about too long. Is some were just wrong.
Yeah, that's true. So we had one example is, for example, the that's probably I've just reorganized it today. Let me see if
yeah, we don't. If there's at least one at all that's
At
different.
least one is different.
Yeah, then right there, I think that maybe that's a good indicator for the least amount of things that we would be required to update to be spec compatible would definitely be appreciated from our engineering team. And so if there is a general, here's what we should all aim for, but as long as we just say you're good or pass fail, and we can all agree on that, and we can get to a spec compatible, where like technically these two implementations are now spec compatible with the least amount of work and changes, that would be ideal.
Stephen?
So this is a different topic, but since we're at time, I just wanted to throw something out there. Some food for thought for in between meetings is a keys related issue that I've been kind of like sitting on, and then finally just said, let's just throw it out there and see what you think. So there it is. I'll link it in Slack as well.
Awesome.
Okay.
Yes, yeah, I also thought that.
Worth considering.
But there are difficulties, but let's discuss it.
It's about the composite keys, right?
Yeah. But
yeah, we can pick this up next week. We can think about what we do with the validation rules here. I'm fine with that too. I would say you definitely maybe should also mention this in the post-merge validation step, that you should actually the schema has to be valid against the graphical specification. But I hope that's obvious. But I'm not sure about dropping the rules. Looking at the rules, a few things are here wrong anyway, because literally, I mean, provides is only really subgraph local, right? So it's one subgraph that provides data over a specific path. So this one doesn't even have to be here. I just missed it. This can be a source schema validation rule. And require invalid fields is one that could be simpler here, but maybe we can also make it pre-merge validation. Yeah, it's hard. These are all based on what or many of them are based on what Federation at the moment provides as errors. So give it a read and think about it, I believe.
yeah, we could also just call out per rule this is actually covered by the schema validation rules. If you throw an error, it's also okay. We recommend that you have this implemented. I think from reading it in one place, it would be easier as if we split them.
So the thing is, we have we have examples and we have explanatory text to it, right? So we say how this can happen in the specification, and it can happen when you, for example, do where's the counterexample? When you do this, none of the queries are accessible.
What are your thoughts, Kamil?
Sorry, with inaccessible?
No, with regarding the rules, splitting them into an appendix, just calling them out one by one that they are things, or grouping them. Like we have a couple of ideas how we, because like Benji's remarks are correct. Like these are technically, like once you would load the schema into a valid GraphQL schema object, it would just fail, right? Would say, okay, query is empty, is not allowed, or query type is missing, not allowed.
I mean, like if let's say we have like for example with the no queries, right? Whether we name it like no queries or no queries field, if we pass it to like GraphQL validation, it will say, oh, you have no queries, right? But there is no reason, like, oh, why it's happening, right? With a custom validation rule, like within the spec, we can, you know, define that it's because of the intersection, or like the fields were inaccessible, right? So I would leave them in the spec, to be honest. Also the other ones, because then you have like all the context. And we can even like, if we go deeper with the error messages, we can even define the context of those errors. So we could point to users, you know, where this field was originated from, when it was, you know, where it was annotated with inaccessible and so on.
If we were to add more information to the main GraphQL spec errors, like the validation errors, would you be able to derive these results from that? So for example, you could have that the no empty objects, I forget what the validation rule is called, but the no empty objects validation rule could say it's this error code, like the validation rule itself, let's say, and it applies to this type, the query type, which you happen to know is the type that is used for the query operation. And you could then take those two bits and combine them to know that the end result is there are no query fields. Similarly, there's a whole number of other things you've got here, like inaccessibles and stuff, but just knowing that like the GraphQL spec is saying that this field does not exist on this type. If we gave you that information, field doesn't exist, this type name, this field name, can you then use that data to then go, that should be there because it's marked as inaccessible and that's why it's not present, that kind of thing. Rather than having to like define the whole algorithmic steps for each of these. Because honestly, it would be an improvement to the GraphQL spec to put this kind of information in. This would be useful information for tooling to use to figure out what has gone wrong. So rather than having you put all this work into the Composite schema spec and have everyone who implements that implement it, why not have every spec implementation also implement it? It
But
seems
how
like
would you-
useful info.
How would you have, like with inaccessible, for instance, the problem is that if I mark something on one source schema inaccessible, it also affects the other source schema. And that means like the two teams that might not yet talk with each other, by accident, one guy puts a directive on his schema and it affects basically also the other. How would you get this kind of context into a core spec
I don't think it's about this kind of context. It's more about if we run the validation on the output schema, on the public schema
Yeah.
we have merged, and the validation, the graphical validation tells us that, hey, I don't know, let's go to good example is inaccessible type, this one. And the
Yeah.
validation of the graphical validation would say, hey, there is no input type 2. It's actually used in this location. Would that be enough context for us to know, to tell the user that, hey, you probably...
Okay, so this way you mean, okay, we run basically from algorithm, we run the graphical schema validation rules, and then we analyze and we tell you what is actually the wrong.
That's what I'm trying to say. Yeah, essentially that.
Yeah, okay.
However, I realize that that's not necessarily quite right either. Are you actually validating like SDL here? Because what you have in the examples here is STL.
Yes, it's SDL. You are merging
Okay.
SDL essentially.
Okay, I'd need to think about that because I think a lot of the GraphQL spec operates on
Schema
GraphQL schema objects, not on the SDL itself. So for example, the situation here with input 2 doesn't exist, couldn't exist in terms of schema objects because either it exists and it is there, or it doesn't exist, in which case we don't know what it is because it doesn't exist.
And that's also the thing with like Glenn is implementing that at the moment, the whole composition, and there is no schema object. Basically, he operates on the language part of our chocolate. So has the parser, has the syntax tree, and builds his own state. His own state, like it's very similar.
From an implementation perspective,
Yeah.
we couldn't run it on top of our
No.
validation. It wouldn't be possible because our validation would not work with this as well.
Yeah, you need an invalid schema in parts. Like also the state must be possible to invalid, to be invalid.
Interesting discussion.
I mean,
Yeah,
there's also like things like directives, some kind of metadata that you want to pass to, you know, whatever. I did the composition for Federation, the library, and I also used just pretty much the document node from JS and like custom state. Like I ditched the idea of like building schema and stuff.
Yeah, we also second try we ditched all this. we are basically custom state plus a parser, like AST, and that's also especially like with the building the graph, because you can like it's the validation step after that, the satisfiability is also a lot on top of that.
Well, there
Like
have been a number of discussions recently about adding a validate SDL method to the spec and to GraphQL.js, for example. There are things that validation doesn't do currently. For example, it doesn't on the SDL actually validate that, for example, directives are valid in SDL. It does perfectly fine on operations, but in SDL, like you can define a directive that accepts, say, like an int argument, and then you can feed a Boolean into it, and it doesn't care. Like,
yeah,
relay
so
defines arguments on the fly because we didn't have fragment arguments.
Yeah, absolutely. So there's all sorts of issues like this, which would be, I think, good to bring to the main working group. Like validation of SDL is a topic that is happening at the moment anyway. So if we add that to the spec, we could add error codes at the same time. And then would that simplify the composite schemas specification? Because a lot of that work would be coming out of some shared tooling that already exists, rather than being something very specific to this spec.
Yes, we can explore that and can see in which direction this goes. Definitely. I mean,
yeah, I think what's important
here is
important here is that necessarily validate in post-merge validation just the STL output. For example, here we say, let fields be the set of all fields across all input types in all source schemas. And that's deliberate, because you want to validate something based on the source schemas, and you want to match if the thing that you're validating is actually in the public schema, right? So you're gonna, what happens here is in the merge, you lose a non-null field, because we merge by intersection. And now you have in the merge, you have a non-null field, which is hidden. And now the post-merge validation rule actually checks if this is in the composite schema.
Yeah, inaccessible is responsible for a lot of these validation rules. Why you can have an invalid schema.
The thing is, the reason we had it differently, we had it all as validation rules before the merge, but it gets really tricky at some point because sometimes you have to merge to know the context. We had this, or we still have it in here, the is exposed algorithm, which was never really properly defined. But is exposed essentially was just checking if a field is in the composite schema. Now that's very problematic because you have to merge to know if something really is in the composite schema. And it doesn't matter how it's removed. So here it says inaccessible, but we probably will rename this one, because if you think about it, it doesn't matter how it's going to be removed. Is it removed because we removed the type was declared as internal? Is it removed because the type was declared as inaccessible? Is something removed because we merged it by intersection? Then maybe that's these rules would still have to be in here, or we put it as pre-merge validation rules. That's also fine.
When you validate like an operation in GraphQL, you could, within your rights, you could just, I think, you can just stop when you see a first error. You can just be like, nope, this is invalid.
Technically, you can also implement it like that. Like
So,
also,
go on.
Yeah, also the whole thing here, you can, like, it's not, the whole spec is not written in the way that it might be the most efficient way, but that is the most understandable way. Like there could be, you could also do everything in, like technically you could do everything during the merge. So you start merging, and then on the first thing that goes wrong, you just fail. Might not be the best for the user, because then you always get, okay, this is wrong and this is wrong. And it might be better you get a whole list of issues that you can just work through. But it's like technically up to you.
Yeah, and I think that's really important. I think that's really, really important, because we want to be able to let people build implementations of this specification in whatever way they see fit. They shouldn't all just be exact carbon copies of each other. They should be like observably, when you talk to them from outside, they should do the same thing. You know, they should work with the same sub-schemas, and they should end up with the same schema being produced. But the way that they go about combining them, whether they run the validation rules first or whether they do it whilst they're doing the merging, that should be up to them. Essentially, either the schema is valid at the end, in which case it should be the same, you know, for everyone, the end result is a valid schema, or the schema is not valid, in which case it's just a case of like telling people why it's not valid. And that's down to the implementation, I think. Like you absolutely can give them more information, and you should give them more information, but I'm not saying that you must give them more information. Just saying this schema doesn't compose is like the minimum requirement, I would say, and that would also be okay.
Yeah, we kind of like, I still think we should have the algorithms there, but we should call them out as this is optional, where you recommend you to have it. But it's enough and we can have like a preamble. Some of the like already calling it out in the preamble. Some of the rules are already covered by the graphical schema rules, and it's enough to just run the graphical the schema validation rule on the public schema, the output, and if that fails, then it's broken. But we recommend you to output these specific errors to give your user more context.
That's not, it's not that's important. I think that's a must. I think we have to explicitly say the schema that comes out of the merge process
must
be
valid.
a valid graphical schema.
That's
this is a must.
One reason that's really, really important is because the GraphQL spec itself may evolve beyond the composite schema spec, or they may be out of step, in which case at the end result, once you've merged in this new type that the GraphQL spec has talked about, you still need your composite schema to be valid, and it may not be anymore.
Yeah, I think this is good. Let's put like in the schema composition at the beginning, we call that out, and then we call in each of the optional rules out. This is optional. Kind of, we recommend you to implement it with this error, because then you can read it in one thing. I think putting it in the appendix would be confusing, because it also is like from the reading flow, it's better if it's together.
I agree. Putting it in an appendix would be generally skipped. Like, because kind of like it's optional, right? If you put it together, it actually, and have a note that this might be, covered by just GraphQL validation in general, might be good enough. But I wouldn't put it in an appendix.
Yeah, that makes sense to me as well. Also, I wouldn't use the word optional. I would use recommended.
Yes.
It's a stronger word.
Okay, so that means all rules which are not covered by the graphical specification, the graphical validation,
are required, and all rules that are covered by the graphical validation, which we have better error context for,
and there will
are recommended.
There will no longer be a pre and post merge validation, I believe.
Why?
Because it's not necessary. It's only this rule.
Yes, well, it would still, we leave the chapter as is. We just call out in the beginning of the chapter that the important thing is like the wording. We can work on that, but that the important thing is after we merge the schema, the output of that must be a valid GraphQL schema and point to the core specification as the validation source. And then in each rule that is actually just providing better error context, but already covered by the core spec, we just say this is a recommended error that we recommend to implement, but that is essentially covered.
Yeah, I think I would keep what you've got, essentially. As Michael says, I would change the level of the requirement, and I would probably add 3.6, resulting schema must be valid. Literally an extra thing right at the end, because it's the lowest priority, it's the lowest information message, but it is also a check that needs to be true at the end of this process. At the end of this process, you must have a valid schema.
Okay, yes. Yes, this is actually better, because you say, okay, this is a rule, this is a validation rule. You have to validate that the schema is valid. And then we just make the other things a different level.
So the question is, if we move one rule out, you have two rules in here, 3 or 4, which don't belong in this chapter. If we move them out, then we can say we have recommended rules, which could be an appendix, and then the post-merge validation rule.
No appendix, Pascal. Leave it as is.
Okay.
Because appendix, then you break this thing apart, and this is from the reading flow and understanding flow is not so good.
Yeah,
just
I
have
want to
we
keep
just
them. I want to keep them in because not because of this. I want to keep them in because of this, which explains how this state can happen.
yeah, exactly. That's why I also would have them there. And
Yeah.
then we just have a 3.5, which is or it could also be just part of the post validation. Ensure that the schema is valid according to the graphical core spec, and then we anyway have still satisfiability on top.
Ideally, if it's possible, it would be great to make it so that sections that only have recommended and not required rules are essentially skippable. So this is what I was mentioning before with like the required post-merge validation versus the optional or recommended post-merge validation. That way, if someone's in a rush, they can just jump to the end.
I think we can actually do all of the rules that are here. We can probably make recommended.
Not all of them, but
Yeah, but the ones which are not, we can move. Because if I can show you a few examples. You know, it doesn't matter if I go through all the source schemas and then check if the field is in the composite schemas. I can also go through all the source schemas and check if any of the source schemas do not define this field in the input type and then throw the error there. It's the same thing. It's just happened to be there while implementing the rule. But thinking about it more with the knowledge that we have now, I think we can make this is wrong, this doesn't need to be here. This is wrong because that's also subgraph only. This one might be, yeah, we'll see. I will figure it out.
let's go through them and then see.
I don't think that this is particularly important, but if it's something you can stick to, it would be nice. Ideally, you would have the pre-merge validation being sufficient so that you know that merge will succeed and the end result will be valid. That would be amazing. That would be a really great situation. Then adding like, you know, the schema must be valid as a final step just as like an assertion, really. You already know it should be valid, but like, let's add an actual check for that. That would be great.
Technically, that is possible. We just are worried, or the why we split it this way is that if you do it pre-merge, the algorithms could be really complex.
Yeah, and you should prioritize the simplicity of the algorithm. So long as you're not requiring that they happen in a particular order, you should prioritize making the algorithms easy to understand rather than worrying about performance of it or whatever.
Yeah, that's why we have the technically the post.
Just to say, we have 2 minutes to switch the meeting. So if you want,
Really? Okay.
if you want to do a bio break, it's your time now. I will take this offline with Michael, and then we'll see what I can do because I really have to go through the rules, and then let's see what the end result will be.
Awesome.
Okay, cool.
Great work as always. See you in a moment.
See you in a moment.
See you.